Hello everyone! In today's tutorial I will be showing you how to work with the AlloViz graphic user interface plugin for the VMD software. In order to initialize it, you first need to activate an environment where you have both VMD and AlloViz installed. To start both VMD and the plugin at the same time, you should run this command from the directory where you have installed your AlloViz software. First, let's load a new molecule. You can find an example of molecules and trajectories when you install AlloViz in the folder called Notebooks, Data. Here is an example of two structures of the active and inactive state of the human beta-2 adrenergic receptor. Let's load the protein PDB file. Now, let's load the trajectory into our molecule. Select Load Data into Molecule and select the trajectory that you want to load. You can adjust the first and the last frame as well as the stride. To make the loading process quicker for this tutorial, I will choose a stride of 25. After this, we can finally work with the graphic user interface plugin of AlloViz. The first section allows you to select atoms which you want to include in the computation of the protein allosteric network. The default selection is protein and non-hydrogen atoms, and I will keep this selection because my trajectory was already fixed for ions and water molecules, and I don't need to clean any of the selection up. The second section allows you to choose a network construction method. There are four major groups of methods which are based on different structural descriptors. Allosteric networks from molecular dynamics trajectories can be constructed by measuring the correlation between the motion of atoms or between the dihedral angles of pairs of residues. We can also work by quantifying the contacts or the interaction energies between residues. AlloViz works including many different packages that process molecular dynamics data and construct allosteric networks based on it, but it also has its own method. In this tutorial, I will be using atomic displacement as a structural descriptor to construct my allosteric network. In particular, I will be working with the package pytraj. So select the method that you want to use, and let's move on to the filter section. Filtering can allow us to focus on specific interactions and reduce noise. We can use either a single filter or a combination of filters. The filtering can either be done based on residue contacts, the distance between residues in the sequence, or a spatial distance in the structure. If you're working with GPCRs, you can also use the interhelix contacts filter. I will be using the minimum spatial distance filter. Moving on, in the analysis part, we can choose which elements we want to analyze. Edges are pairs of residues, and nodes are single residues. For each element, you can compute two different centrality metrics, as well as the raw edge values. Finally, you can establish a visualizing threshold to only show you the elements that you chose to analyze above the specified percentage. When all these things are set, just click Compute and Visualize. In your molecule display, you will see the output of AlloViz situated on top of your protein molecule. And in the main menu, AlloViz output will be registered as a separate entity. When rotating your molecule, you can see some bars between pairs of residues. These are the edges of the allosteric network we just computed, and the element we selected to visualize. Finally, your computation will be saved in the history sidebar. This will allow you to revisit your calculation parameters, as you can see here, visualize your analysis results. You can also export your computations in a tabular format that will allow you to further process the result of AlloViz. You can revisit the cache generated by AlloViz, which is represented by essentially intermediate files that it generates in its computation, before filtering and after applying the filter. Finally, if you run a new allosteric network computation, it will be saved with all your parameters in the history sidebar. You can easily switch between all your different analyses extract their data, and visualize them separately. I hope you find this tutorial useful and enjoy using AlloViz. Goodbye.